So, how do scientists know that a dinosaur bone is 65 million years old, or that Earth itself is about 4.5 billion years old? They can't exactly check a birth certificate. Instead, they use a method called radiometric or radioactive dating, which relies on a clock hidden inside the rocks themselves. Here's how it works. Most atoms in the universe are stable. They stay the same forever. But some atoms are unstable or radioactive. These unstable atoms, called parents, naturally break down over time into stable atoms called daughters. For example, uranium, the parent, eventually decays into lead, the daughter. The key to this entire process is that this decay happens at a very specific fixed rate. It doesn't matter if the rock is frozen, boiled, or crushed, the rate never changes. This rate is called the half-life. A half-life is the amount of time it takes for exactly 50% of the parent atoms to turn into daughter atoms. Think of it like an hourglass. The sand in the top bulb represents the radioactive parent atoms, and the sand in the bottom represents the stable daughter atoms. If you find a rock and you can measure how much sand is in the top versus the bottom, you can calculate exactly how long the hourglass has been running. Scientists use a device called a mass spectrometer to count these atoms. If a rock has a 50-50 mix of uranium and lead, we know one half-life has passed. If it's mostly lead, we know it's much older. Now, different elements have different clocks. You've probably heard of carbon-14 dating. Carbon-14 decays very fast, so it is used for dating things that were once alive, like wood or bone, up to about 50,000 years. But for older things, like dinosaur fossils or the Earth's crust, scientists use potassium or uranium, which have half-lives of over 1 billion years. So by reading the ratio of atoms trapped inside a rock, we can look back in time and date the history of our planet with incredible precision. Pretty cool.